Okay. The next example I'm going to do will illustrate that. Okay. Wait, am I recording? Yes, I am. Wanted to make sure I was recording. Okay, good. All right. Okay, so let's do an example. Suppose P is the point. Let's say we have the 2 points here, 1, 4, and 2, 7. So let's take P here to be the point 1, 4, the first point. Q is the point 2, 7. Then the distance between them, right? We have x of 1. Here, let me get that pen out. We have x of 1 would be 1. X of 2 would be 2. Right? We have x1 minus x2 squared. Y1 would be 4. Y2 would be 7. Beautiful. Good. So from here, we get 1, right? X of 1 is 1. X2 is 2. So 1 minus 2 squared. Y1 minus Y2, right? 4 minus 7 squared, which is the square root of negative 1 squared plus negative 3 squared, which is the square root of 1 plus 9, square root of 10. So that's what we get here. So that is what we get. Okay, now you might be thinking, why am I doing this? Well, let's suppose P I took to be the other point and Q I took to be the first point, 1, 4. Okay, let's say I did that. So then in this case, let me get the pen out, but let me do that pen thing. Let me change the color of it for fun. Purple. Let's say x of 1 now is 2, okay? And we're going to say x of 2 is now 1, right? Y1 is going to be 7 now, and Y2 is going to be 4. Then, using the distance formula, we would have x1, right, minus x2 squared. That's 2 minus 1 squared. 7 minus 4, right? Y1 minus Y2. That's now going to be 7 minus 4 squared. Okay? Which is, of course, the square root of 1 squared plus 3 squared, which is the same as up here. As you can see, really all that's happening is you're really just interchanging the order in which you subtract the numbers. That's really all you're doing. And because we're squaring, you're going to get the same answer. I mean, if we weren't squaring, then you would have to be careful. And you also have to be careful in that you can only subtract the x coordinates from each other, right? You know, we're not doing 1 minus 4, for instance, or 1 minus 7. We're subtracting the x coordinates from each other and the y coordinates from each other. That's what we're doing. Okay. Are there any questions about that? What I'm trying to say? I really hope it makes sense. Yeah.
I have a question. So let's say that you were plotting point A and point B, like just random points, point A and B on the Cartesian plane.
Right.
And you basically need to find the distance between A and B. So you use the distance formula. And let's say the answer is like 10. Do you say it's 10 units?
I would just say it's 10.
Okay, so there's no like.
You don't know the units, that's why.
So it would just be the distance is 10.
Exactly, or a square root of 10 like I have here.
Okay. All right, thank you.
You're welcome. I hope that made sense. So.
Yeah.
Okay. Good question. Yeah, so we really don't know the units, so you could just leave the number as the distance. Okay. Awesome question. Any other questions? Okay. Now, I know in this math, in mathematics, what we like to do is prove things. And now you might be thinking in this class, wait, we're not supposed to prove stuff. I do want to show you, though, why the distance formula is true. I mean, it's not like someone came along and say, this is it. If you don't like it, too bad. We like to verify why the distance formula is true. It's actually based on a famous theorem about right triangles called Pythagorean's theorem. So we're going to verify the distance formula. Okay, well, let's suppose P and Q were both in the first quadrant. I mean, if you had P and Q, excuse me, I didn't say what quadrant was. Let's say P and Q are both like this. In this part of the Cartesian plane. It really doesn't matter where they are. Okay. So without loss of generality, let's suppose P and Q, excuse me, I pressed the button too soon, too early, I mean. P and Q, let's say without loss of generality, they're here. Okay. Well, what you can do, you can sketch these dashed lines. Basically, what I'm going to do is from P, okay, I'm going to sketch a dashed line down to the x-axis, vertically. Same thing with Q, okay? I'm also going to sketch a dashed line from Q horizontally to the y-axis. Same thing with P, same thing over here with P. Okay? No, and don't worry, you're not going to have to do this on an exam. I just want to illustrate why this is true. I'm also sketching a dashed line out like this until I hit this dashed line. So we have all these dashed lines floating around. Let's see if I can zoom in actually. Oh, yes, that's cool. Okay. This might make it easier. So we have these dashed lines floating around. Okay? All right. Okay. Now, all right. So this is our point P, right? Now, you could probably see there's a right triangle here. That's what this little square here is supposed to indicate. Okay? We have a right triangle. And P and Q is this length over here, the length of this line segment. Okay. Well, what about these line segments? What do we do? Well, this point over here, right? This has coordinates x sub 2, comma, y sub 1. Now, how do I know that? Well, since this point is vertically under Q, right? Remember, if 2 points are on the same vertical line, they have to have the same x coordinate, right? So this point here has x coordinate x sub 2. It's directly under Q. Okay? It also is on this horizontal line segment, well, dashed line segment, I guess, as P. So its y coordinate has to be y sub 1. Hopefully from the picture you can see that as well. So this point over here, okay, has these coordinates. And that's good. Now, why is that? Well, if we wanted to get the length of this over here, right, that's just a change in y coordinates. Right? If you want to go from this point and you want to climb up to this point, how far are you going to go? You're going to go y sub 2 minus y sub 1. Likewise, over here, if you want to go from P to this point, how far do you have to go horizontally? You're going to go x sub 2 minus x sub 1. It's like you're starting from the origin. You're walking all the way to x sub 2, but then you have to ignore this part because you're starting here. Basically, what I'm trying to say is you're going to get this right triangle. Okay? Down here, I basically took away the x-axis and y-axis, so to say. But we have this right triangle here, right? We have the length of this leg and this leg, these two sides. The side opposite the 90-degree angle, what is that called? That's the hypotenuse. And how do you get that side? Pythagorean's theorem. And the length of that line segment is the distance from P to Q. And remember, that's denoted by this. So that distance here squared is equal to the length of this leg squared plus the length of this side squared. And then you just take square roots. I mean, again, I hope that made sense. I mean, again, I'm not going to ask you to prove it on an exam. I'm just trying to illustrate, why the formula is true. No one came out of nowhere and said, well, this is the formula, no questions asked. It's not like that. I mean, hopefully you understood it, but it's really just Pythagorean theorem. All right. Okay. So that's the distance formula. Now, there's also what we call a midpoint formula. But before I get to that, let me just say this. You have to be careful with square roots, though. Okay? Square root of a sum is not the sum of the square roots. And that's what I'm showing you. That's what I'm showing you here. Okay? The square root is not compatible with addition. If you have two positive numbers, the square root of A and B, the square root of A plus B is not the square root of A plus the square root of B. I actually illustrate a special case illustrating this. If I take A and B to be 1, for instance, on the left, I have the square root of 1 plus 1, which is equal to the square root of 2. Over here, I have the square root of 1 plus the square root of 1. But the square root of 1 is equal to 1, so over here I would have 2. So here I have the square root of 2. Here I just have 2, but 2 is not equal to the square root of 2. So this is not true for all A and B positive. I'm just trying to illustrate that. I mean, hopefully I'm successful here, but I think I am. Pretty sure, I'm confident I am. Again, you just take A and B to be 1, for instance, although any two positive numbers will work, and you'll see that these two are not equal.